Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. My name is Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and we are just so excited that you are here with us. If you are new, welcome. If you are not new, well, you can be welcome too. Let's just celebrate the fact that we have merged our Facebook groups. So that's super exciting, and I just want to shout out there that we do have some giveaways going on in our groups. So I think if you, and I'm like trying to scroll to see, I think if you like post an introduction of yourself with like a picture of yourself, then you are entered into winning a gift card. And so if you haven't done that already, make sure you head to our Pass Your Praxis, FTCE, TExES, and MTTC exams. I'm going to actually copy the link and post it here. So make sure you head to that group. If you're not part of it, join it and introduce yourself to the group. I think you get entered into a drawing for like a gift card. And I think it doesn't end until Friday. So that's pretty awesome. Hello, Edith. Hello, Latrinda, hello, Lee, hello, Darren, hello, Leah. I love seeing your face, Leah. Even though you have passed your exam, you are still hanging out with me on Wednesday nights. I love it. Welcome. We are going to go through some problems tonight that are going to help increase your competence and your confidence in math. So make sure that you pay attention. The problems that we are going to go over range from K to 12. If there is something specific that you want, so a lot of the problems tonight were actually specifically requested topics or problems by individuals. And so if you're like, man, that really didn't help me because I'm studying for elementary or I'm studying for pre-K and you didn't do enough of that or you didn't do enough high school, make sure you let me know in the comment box. I always have like a next week section, and I am happy to include stuff for the upcoming weeks. Now, remember, we are taking a 2-week break, so we will not be here next week or the following week due to the holidays. Next week is literally Christmas Day, and then next week is literally New Year's Day. So we will not be here next week or the following week, but we will return on January 8th. So January 8th, we will return strong and ready to go for the new year. But let me know what you want to see from me in the upcoming weeks, and I will make sure I start to prep that stuff for the January 8th and beyond. In the comment box, let me know where you're from, what test are you prepping for, and what is a favorite holiday tradition that you and your family do? Can we all just have a moment for this dress? This is a dress. Is it not the most fabulous dress ever? Like massive sequiny nutcrackers, sequins all the way down. I am literally obsessed with this dress. And so I just want to have a moment for it because why not? Some fun holiday traditions. We do not do like a ham or a turkey on Christmas. We do a crab boil. So that's one fun tradition. My mom and I always go see the Nutcracker with my niece, and we always go to the Christmas Tree Festival in Orlando. So that's super fun. And probably my most favorite tradition that we've started is we have started playing some Christmas games on Christmas. And so we do the Saran ball game and we do the oven mitt present game. If you don't know what those are, you have to look them up. Like, I wish we were all in my living room right now doing this because we would totally be playing one of those games right now, in addition to doing some math. So if you are curious as to what those games are, you have to Google it or find me on Instagram because I'm sure I'll post a video about it when we host Christmas for my family. Hello, Valeria. I'm so glad you made it. Welcome, welcome, welcome. All right. Hello, Denise, Florida Pro Ed. Okay, Denise, I would love for you to stick around. I'm not trying to kick anybody out of this live because the more the merrier. But I will say the only thing we are working on Wednesday nights is math. We don't go over any other types of questions. So if you need math, stick around. If you don't need math and you only need the Pro Ed, then I would say that this is probably not the best use of your hour. Leah, you do not have matching Christmas pajamas. I absolutely am obsessed with that. And you eat Italian or Portuguese food. That's awesome. All righty. Let me know if you have any questions as we're doing this, and we're going to go ahead and get started. Yeah. All right. First problem. Here we go. A high school surveyed 1,000 students. The students were asked how many hours they spend watching TV a week and whether they watch cable or use a streaming service, Netflix, YouTube, Hulu, etc. The results are shown below. What percentage of the students watch TV for 2 to 3 hours? So this is what's called a frequency table. It just shows data in a specific manner. And so we know they surveyed 1,000 students. So I'm going to break this word problem down. We know, okay, why is my pen not working? Okay, we know they surveyed 1,000 students. So theoretically, all of these numbers should add up to 1,000, right? And I'm just going to do the math to make sure. Here we go. 51 plus 156 plus 105 plus 264 plus 87 plus 337 equals 1,000. They were asked how many hours they spend watching cable, streaming service, etc. a week. So these students watch this many hours of cable, and these students spend this much time watching a streaming service. So the question asked, what percentage of the students watch TV for 2 to 3 hours, assuming that both of these are considered TV? Well, my 2 to 3 hour column is right here. So all of these students are watching TV for 2 to 3 hours. It's not the same kind of TV, but all of those students are watching TV for 2 to 3 hours. So I'm going to add these two up. 105 plus 264 equals 369. Now, that's not the answer because they asked us for the percentage of students that watch TV for 2 to 3 hours. Now, even if a frequency table isn't on your exam, elementary people, what is on your exam is converting percentages, fractions, and decimals and really understanding that as a whole. And so when we think about what a percentage is a part of a whole, understanding that the whole is 100%, right? But really, a fraction is also a part out of a whole. So if I figure out what my part and my whole is, and then I divide that in my calculator, then I can figure out my percentage. So my part is 369. And in this case, my whole is 1,000. What answer can I get rid of automatically? The answer I can get rid of automatically is 58%. Because I know that 50% of 1,000 is going to be 500. Half of 1,000 is 500. And this is less than half. Y'all, I'm telling you, no matter what grade level you are taking, no matter what kind of assessment you are taking, it is going to help you to really understand number sense and to understand anchor numbers, anchor fractions, anchor percents, understanding 50%, 10%, a quarter. Being able to really mess with those in your brain is going to be super helpful for you when you are solving problems like this. Because if I'm running out of time and I don't have time to sit here and figure out the percent, or I'm a little confused, I can quickly see that this is going to be less than 50%. I also know that it's going to be more than 11% because 10% of 1,000 is 100. And so 11% is just going to be slightly bigger than 100. And so it's not going to be 11% either. So I can now make an educated guess if I was running out of time. The real way we can do it is use a calculator and just do 369 divided by 1,000. And that's going to give me 0.369, which how do I convert? So I'm now converting a fraction to a decimal to a percent. How do I move through that continuum? I'm going to divide the fraction into each other, and that's going to give me the decimal. And then how do I convert the decimal to a percent? Well, a decimal to a percent, I'm going to hop or move the decimal place 2 places to the right. 1, 2, that equals 36.9%, which rounds to 37%. Questions? Leanne, oh my goodness, that sounds like so much fun. A family gingerbread house competition, and then you destroy the gingerbread houses? How fun is that? That is literally so fun. I want to be a part of that. Can I come over and build a gingerbread house, please? I want to. All right, let's go ahead and move on to the next question. A solution company just invented a new solution. They can produce 1 milliliter for $6.45. I am so sorry, y'all. How much will it cost them to produce 3 kiloliters of this solution? How much will it cost for them to produce 3 kiloliters of this solution? So, In this situation, we are looking at conversions. So when we're doing conversions, we just need to understand what that conversion is. So depending on the test that you're taking will determine if you get a formula sheet or not. So some formula sheets have conversions on them, and some formula sheets do not have conversions on them. If it's an unknown conversion, then the problem will typically give it to you in the problem. If it's a known conversion, then the problem will either expect you to know it or it'll be on the formula sheet. So in this situation, this is a known conversion that we should know. So we are looking at a milliliter. They can produce 1 milliliter for $6.45. How much will it cost to produce 3 kiloliters? So my first step is to convert 3 kiloliters into milliliters. Because once I figure out how many milliliters I have, then I can multiply by $6.45, right? So I just need to know how many milliliters is in a kiloliter, right? So when I think of like a metric conversion chart, which is really what we're looking at, when I think of a metric conversion chart, I think of my base unit. So I have my base right here. And then it goes deci, centi, milli. And then this way it goes deca, hecto, and kilo. Now I'm going to highlight the ones that we typically see the most. So like you often hear about kilo, you often hear about milli, you often hear about your base. So like if my base is liters, then I could have deciliters, centiliters, and milliliters, and I could have decaliters, hectoliters, and kiloliters. But a lot of times like if I'm talking about meters, not liters, I could have a centimeter or a millimeter. Like that's kind of common, but I don't often hear centiliters, right? And so when I'm going in this direction, I'm going to multiply. And when I'm going in this direction, I'm going to divide. And each of these is by 10. So I'm multiplying by 10 or I'm dividing by 10, right? So if I have 3 kiloliters and I want to figure out how many milliliters that is, I'm going to multiply by 10, 10, 10, 10, 10, 10 to get there. Don't mistake that for 10, 20, 30, 40, 50, 60, because it is not 60. It's 10 to the 6th power. I would typically go 3 times 10 times 10 times 10 times 10 times 10 times 10, right? Like this is just how my brain works. Or you can do 3 times 10 to the 6th. I'm going to do it in my calculator, but it really doesn't need to be done. In fact, it doesn't need to be done in the calculator. 3 times 10 to the 6th. I can move my decimal 6 places to the right. So 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So this equals 3 million milliliters. Multiply that by $6.45. $3 million times 645. My calculator is locked. 19,350,000 is our answer. Now, this one was not multiple choice because some of the tests that you guys take do not limit themselves to multiple choice. Some assessments have fill in the blank, stuff like that. And so it's important for us to recognize that sometimes we could have a fill in the blank. If you're not sure if you have fill in the blank or not, it's important for you to look at your blueprint or your map that you have, and it'll tell you what kind of questions you can expect. Yes, Leah, you are absolutely correct. Leanne, I'm coming over. I'm going to participate in the gingerbread house. We're going to destroy them together, and then I'll come ready with the oven game, and we can just Christmas game it up. Anybody else with me? Please join. We would love to have you. All right, let's go ahead and keep going with the next problem. The games have been sorted into video games and board games. The number of video games is 28 less than 6 times the number of board games. The games are 80% video games. How many board games are there? 8, 10, 13, or 14? So when we are looking at a problem like this, I always like to say answer choices are your friend. So sometimes we can solve it algebraically and it's super easy. Sometimes just using our answer choices is going to be more helpful than solving it algebraically. So let's go ahead and explore that a little bit. So we have video games and board games. The number of video games is 28 less than 6 times the number of board games. The games are 80% video games. How many board games are there? So the question really tells us what the answers are. These are board games. So if those are board games, then how many video games do I have? Well, the number of video games is, everybody needs to be able to take a word phrase and translate it into an algebraic phrase. So video games equals 28 less than 6 times the number of board games. 28 less than 6 times the board games, and we'll call that a B. That is not correct, and I wrote it like that on purpose. If it was 28 more, then it wouldn't matter, because 28 plus 6B is the same thing as 6B plus 28. However, 28 minus 6B is not the same as 6B minus 28. 28 less than literally means something minus 28. Think about it this way. If you're not sure which way to do it, if I said, what is 5 less than 8? What would your answer be? Your answer would be 3. Not because you did 5 minus 8, but because you did 8 minus 5. Something less than something is something minus that item. So this is going to be 6B minus 28. So I'm literally going to take these numbers, plug the board games in, and solve. 6 times 10 minus 28. 6 times 13 minus 28. And I wouldn't necessarily write all this out. I'm just writing it out for visual purposes. I would just use my calculator and figure it out. 6 times 8 minus 28, 20. 6 times 10 minus 28, 32. 6 times 13 minus 28, 50. 6 times 14 minus 28, 56. So that's how many video games there are in each scenario. Now, how many total games do I have? You'll see where I'm going with this. 28, 42, 63, 70. Why did I come up with my totals? Because, and it just disconnected, so we're just going to reconnect. No big deal. Because it then says the video games are 80% or something like that. And so if I'm going to figure that piece out, then I need to know what my total is so I know what my part of my total is, right? And so the games are 80% of the video games. The board games are 80% of the video games. No, the games are 80% video games. Sorry. I read that wrong. So the games are 80%. So this is 80% of this, which means I should have way more video games to board game ratio, right? So this ratio right here is not an 80% ratio at all. I can visually look at that. How do I do this mathematically? I'm literally going to multiply 70 times 80%, 63 times 80%, 42 times 80%. I'm going to start down here because it's the largest gap and I want to see what I'm working with. 70 times 80% is 56, which means this is the correct answer. So we almost worked backwards to go forwards to figure this problem out. Questions? Hey, Hope, it's good to see you. No questions. All right, let's go ahead and move on to the next problem. This was specifically requested by somebody. A store owner wants to set up a rectangular sale zone to display sale items on the pavement outside of his store. He will use one side of the building, which is 35 feet long, as part of one side of the display area. He will use 210 linear feet of fencing material to fence in the remainder of the display area. Let X represent the length of the side of the rectangular sale zone, which is opposite the building. Write a function that expresses the total area A of the sale zone in terms of X. This is a good problem. All right, so this is a lot of words, and this is what intimidates people. So we have a store owner wants to set up a rectangular sale zone. So we know it's rectangle to display sale items on the pavement outside of his store. So let's call this his store. And let's call this his sale zone. He will use one side of the building, which is 35 feet. So this is 35. As part of one side. So the reason I knew not to do store and then sale zone was because it said that one side of the building, which is 5 feet long, was part of one side of the display area. He will use 210 linear feet of fencing material to fence in the remainder of the display area. So he's got some fencing. So from here to here to here to here to here is going to equal 210. Let X represent the length of the side of the rectangular sale zone. That was a lot of words. Let's say that again. Let X represent the length of the side of the rectangular sale zone, which is opposite the building. So they are defining this as X. What is the area? Excuse me. Woo! So I know that all of that is going to equal 210, right? So perimeter equals 2L plus 2W. Are we in agreement? And all of that has to equal 210. So if this is X, then this side is going to be X minus 35. Agree? So X plus X minus 35 plus, and let's say this is W and this is W, W plus W all has to equal 210. Agree? So now I have 2x minus 35 plus W plus 2W really equals 210. Agree? And so I can add 35 to both sides. So 2x plus 2w equals 245. And where is that going to take me? Well, isn't that just interesting? Write a function. Y'all, I just got stumped live on YouTube. So what I can tell you is that if you were solving this problem, I can cross off A automatically because this, in order to have an area, I'm going to end up with an x squared because I'm going to have my variable represented here in two different ways. So I know that I have to have an x squared. So I know that it's got to be B or C or D. Which one that is, I'm going to have to solve this problem on my own and really think about it in a way. Now, could I figure out the answer on my own? Yes. But I want to figure it out in a way that makes sense to you when I explain it. So here's a really human vulnerable moment where I just got stumped live on YouTube. So I'm going to table this problem. We will bring this problem back on January 8th. Or maybe I'll just solve it live or solve it in a video and post it to our social media as like a fun little math problem, just so that you guys have the answer before January 8th. But let's go ahead and move on to the next problem. I just got stumped. All right, moving on. Which of the systems of inequalities corresponds to the graph below? Which of these systems of inequalities corresponds to the graph below? So anytime I have a problem like this and I see a solid line and I see a dotted line, I'm going to immediately go to my answer choices and cross off any answer choices that don't have like a greater than or equal to or a less than or equal to mixed with a greater than or less than. Because a solid line is represented graphically. Well, let me rephrase that. A greater than or equal to or a less than or equal to is represented graphically by a solid line, and a greater than or less than is represented graphically by a dotted line. Now, all of these answer choices have greater than or equal to or less than or equal to. All of my answer choices also have the symbol pointing in the same way. So all of my first equation are less than or equal to the function, and all of my second equations are greater than the function. So at this point, I just need to figure out which function is which. So I see that I have a solid line parabola that's tracking here. And this is going to be x squared plus 3. How do I know that? Because these all represent vertical transformations because they are outside of the parentheses of x. So these are all vertical transformations. And this is an upside down parabola, which means my x value, x will be negative. So I need to look for a negative x squared plus 3. A negative x squared plus 3. Where do I have that? Negative x squared plus 3, negative x squared plus 3. Those are my only two options. Now, the negative x squared plus 3 graph has to have the solid line, which means my only possible answer choice is C. And I didn't do a whole lot of math to figure that out. My only possible answer choice is C, because I had to have a negative x squared plus 3, and there's only 2 options for that. And the negative x squared plus 3 is a solid line, not a dotted line. And so it has to be C. And so last week, if you were with us, my iPad never disconnected one time. And this week we've disconnected twice. It's par for the course. It is what it is. All right. So now let me chat with you about real quickly what happens if it wasn't that easy. Well, I also can look at this graph, and I see that this graph has a dotted line, and this is going to be positive x squared because it's facing up. And I'm going down 3, which means I'm vertically transforming negative 3. So it's going to be x squared minus 3. Now, what if my symbols were facing all different ways? How do I know that this is the graph for me? Well, at that point, you can pick the point 0, 0, plug it into both of the equations that you have. And if it works, then you've picked the correct one because it's shaded on top of that 0. So many different things to think about, but this is the perfect example that you don't even need to fully understand the problem. You just have to understand very basic graphing of inequalities and quadratic functions to be able to solve this problem, because we were able to use process of elimination to figure that out pretty quickly. All right, let's move on to the next problem. All right, that one I forgot to put in the graph. Which of the following functions correspond to the graph below? There is no graph, so we're going to skip it and move on to the next problem. The population of a bug is a function of rainfall and can be approximated by the formula n of x equals 1,000 plus 21x squared minus x cubed, where x is the number of inches of rainfall. Find the values of x, if any, of which the population is at its maximum. Find the values of x, if any, of which the population is at its maximum. All right. So in order to figure out this problem, in order to figure out the answer to this problem, we have to first understand what this problem is asking. So we have a cubic function here. X cubed is the largest. We have a cubic function. And really, all of these words are really useless. What we want to know is find the values of which this is at a maximum. So if I were to draw what I like to call a baby graph, like a very, very rough sketch of this graph, just understanding end behavior and minimums and maximums, I know that my graph would look something like this. And you say, how do you know that? Because my highest degree is a negative. And so that means I'm going to be going down first and then coming up and ending down. So a positive cubic function is going to start up and end up. And when I say start up, I mean start trending up. The end behavior is pointing down, but my pencil is going up. And a negative x cubed function is going to end in the negative, and my line is going to be decreasing. That's a better mathematical way of describing it. So with all of that said, I need to figure out the value of the maximum, if any. Now, this is called a relative maximum because it's not an actual max, because my maximum is a concept represented by infinity, right? And so if I'm trying to find the relative maximum, I have to find the first derivative. So to find the first derivative of n of x, I'm going to drop the 3, negative 3x squared, drop the 2, 21 times 2, 42, and then that goes away, right? So there it is. And then I'm going to set my first derivative equal to 0. And that's going to show me if I have a relative minimum or maximum. So 0 equals negative 3x squared plus 42x. Pull out the x, right? So x equals 0, and I'm going to finish this like way up here. And negative 3x plus 42 equals 0. Add 3x to both sides. 42 equals 3x. Divide both sides by 3. Honestly, and x equals 14. Whoa, whoa, wow. What is my iPad doing? X equals 14. So for a problem like this, it really isn't complicated if you understand relative minimums and maximums and basic calculus. So if I'm trying to find a relative minimum or maximum, I'm just going to find that first derivative. And once I find that first derivative, I can go ahead and set the derivative equal to 0 and solve it. Like all of that is very basic calculus math. So if you understand all of that, then this becomes not a word problem, and it really just becomes find the relative maximum of this problem, right? Questions about that? All right, here's what I'm going to do. I encourage you to go check out our new Facebook group in the comment box. I've pasted the link to the new Facebook group in the comment box. I'm going to paste it again right here. If you have not already done that, go check it out. And in fact, on the page of the Facebook group, it says our free math prep Wednesday starts now. Tell Amy that Jackie sent you. So if you go check out that Facebook group, comment and be like, I was there. Just so that people know that you were here. We want to see more people here, hanging out with us for math night. I mean, who wouldn't want to spend math night with us? And then make sure that you introduce yourself with a picture, because you can be entered in to win a gift card if you do that. I'm trying to find where that was, just to make sure I'm not Yes. Okay. So we have a third giveaway. Just post a picture of yourself, introducing yourself to the community, and share why you're excited about being in this community moving forward. We are running that contest until Friday, December 20th, and we will pick a winner on that day. So head on over there. I'm going to do it right now. You head over there and do it too. I want to see all of you who are here introducing yourself. Hope, Leah, Leanne, Latrinda, Valeria, Edith, Darren, I am holding y'all to it. And whoever else is watching this video who didn't introduce themselves in the comments, I want to see you introduce yourself. Let us know who you are, why you're excited to be part of the group. And y'all, you could win a gift card. That's extra holiday money. So I will see you there. I'm going to turn it back over to Dr. A. And I'm going to go introduce myself. So go introduce yourself right now, and I will see you. Y'all have a Merry Christmas. Have a happy Hanukkah. Have a happy New Year. And I will see you on January 8th. I'm going to miss you. I really enjoy hanging out with you. I'm going to miss you. Think about me. Did you miss a math prep last week? No, I was sick. In fact, if you listen, you can still hear me getting over it. I was sick last week, so you didn't miss anything last week. And if I missed any problems that you wanted me to go over, just re-message them to me because they might have gotten buried. But you did not miss anything. No, absolutely not. All right. I will see y'all next week. Not next week. I will see you all after the new year. Have a great holiday season with your families, and we will see you later. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.